So let's start. This is a build after party meetup. Let's talk about everything you would like to know about Power BI Datamarts. A few weeks ago, we had the build conference, and one of the big news of the build conference was the Power BI Datamarts. So let's talk about them. First, a bit about me. My name is Denis Torres. I'm a data platform MVP. I work on the Tower Software company in Malta. I'm a trainer with some Microsoft certifications, and I'm the leader of the Malta Data Platform User Group. Since you are here on this meetup, you already know our meetup link. We have also a Facebook page and some other links. And you can see also my contacts. It will be a pleasure to stay in touch. You can see my site, Facebook, LinkedIn, Twitter. It will be a pleasure to stay in touch. So let's start talking about datamart from the very beginning. What we'll talk? What's a single source of truth? We start from the very beginning to understand where the data mart is positioned in the market and in the Power BI architecture. So we talk about what's a single source of truth, the traditional data warehouse architecture, what's a data mart, exploratory versus explanatory analysis, and the Power BI data marts. What are the Power BI data marts? Data mart is a concept in relation to data intelligence. And now we have data mart as a feature inside Power BI. So it's important to don't mix them, although they are very related. The Power BI data marts have the intention to build data marts, to allow us to build data marts. So what's a single source of truth? A single source of truth is something that every company should have, because the opposite would be completely craziness. The opposite of a single source of truth would be completely craziness. Imagine if you have many people building dashboards, building reports, making presentations with data, lots of data, and sometimes the same information. For example, how many customers the company has will appear as one number in one place, another number in another place, a third number in another place, and so on. It's completely craziness when the company doesn't have a single source of truth. It's a completely crazy scenario. In my home country, we have an old saying that when someone has one watch, that guy knows the hour, knows the exact time. But when someone has two watches, the guy doesn't know the time, he only knows the average. That's the point. That's the point. So we need to have a single source of truth in our companies. What's the idea of the single source of truth? We need to have centralized data, and the centralized data for the company becomes company intelligence. It becomes company intelligence. Multiple applications needs to be integrated. I'm not saying that the applications need to be integrated. The applications are production applications. It's common that every company has multiple production applications. This is very often to happen. But the data of these applications needs to be integrated and become a single source of truth, a single source of all the facts which are happening inside the company. The company needs this single source of truth. and multiple models needs to be integrated. This is the consequence of the previous one. We are integrated multiple applications. These multiple applications have different models, and these different models needs to be integrated in a single model, which will expose the history of what is happening inside the company. What are the facts which are happening inside the company? And so our information needs to have a single source. We need to retrieve the information from a single point. If we try to retrieve an information from multiple different places, the same information in multiple different places, it's like someone with two watches or even more. We will not have the information, we will only have the average. That's the point. So let's talk about the traditional data warehouse architecture. Why I'm going to the traditional data warehouse architecture? Because the data warehouse usually is the single source of truth. It doesn't mean that every company has a data warehouse. No, not really. Many companies don't have a data warehouse, but this would be a good scenario. If the company can't immediately have this scenario, the company should be working towards this scenario to reach this scenario. So the data house can become a single source of truth. So we have many data sources. We can use ETL tools to ingest the data from these data sources into a data warehouse. Or nowadays, considering the amount of information that we need to deal with, information coming from internet, logs about our applications, and so on, we even talk about this as a data lake house, a mix of data house and data lake. In fact, these are two different technologies, but we consider them as we can consider them as our single source of truth. But usually, this data lake house, this data house and data lake together, they have quite complex structures. These complex structures will not be user friendly. These will not be user-friendly structures. So it's possible to retrieve historical information from a data house. A well-built data house can answer any questions from the CEO of the company. Any questions can be answered by a well-built data house. But not immediately. The information needs to be investigated. A data analyst needs to investigate the information from the data warehouse to find the answer to the questions. This sometimes this usually takes time. So most of the times, the end users don't deal directly with the data warehouse. The end users use more focused models for the end users. These focused models, sometimes along the time, they receive the name of cubes. Some technologies build them as cubes. They are also received the name as semantic models. The idea of them is to be more focused models and to be user-friendly and focused in one specific area of the company, sometimes in one branch of the company, sometimes in one specific set of facts of the company, and so on. These subsets, these data models, which are subsets of the data, they will not have answers to all questions which could appear in relation of the history of the company, but they could have answer to a huge percentage of the questions which could appear. 80%, 90%, or even more, these answers could be in these focus models. And the few questions that these models would not have be able to answer, these questions could be researched inside the data warehouse. And Power BI is located at the moment exactly in this area. Power BI is located exactly in this area. It helps us to build focused semantic models which are user-friendly, and build reports from these semantic models and provide these semantic models to our end users. That's a huge set of tasks that Power BI help us to do. Besides the fact that Power BI help us to do all these tasks using a self-service approach. This means that the the data analysts who will be building Power BI solutions, the analysts building this solution, don't need to keep stuck to the information which is in the data warehouse. They can capture their own information. Sometimes the data warehouse is built by a main office of the company, and a local branch has additional information which was never included in the data warehouse. The IT team would reply that, oh, it's on our backlog. As soon as we can, we include this information in the company data warehouse, but we couldn't do that yet. But meanwhile, while the corporate IT team can't include those information in the corporate data warehouse, the self-service power in Power BI allows the user to mix this information with the data warehouse information. So all this is a very good scenario, a very interesting scenario. And what is a data mart? A data mart is a subset of the data warehouse content. It's focused, is intended to be focused, user-friendly, more than the data warehouse. The data warehouse can have complex structures. For example, slowly changing dimension. This is something that the data warehouse can contain. It's a complex structure that could be inside the data warehouse, and an end user will not be able to deal with this kind of structure. While in a data mart, we would solve this, let's say that in this way, solve this structure to show the, let's say, the most recent information or the information which is relevant for the scenario of that data mart. Sometimes is a semantic model, sometimes we build the data mart as a semantic model, being very user-friendly. A data mart can be a self-service data mart. It means produced by the data analyst, local data analyst. Data analyst is in one company branch and not by the corporate IT, or can be provided by the corporate IT as a subset of the data warehouse. So we see two methods to produce the data marts. A self-service method or an IT provided method. And you may maybe notice by all these definitions that I'm highlighting here at this point on my screen, in relation to all these definitions that we are seeing here, you may be noticing that this is the definition, this is the definition that we saw on the previous slide. This is the definition from the previous slide. Here, in relation to what Power BI builds for us. From the data house, Power BI builds focused models for us. So Power BI builds data marts for us. That's it. The definition fits perfectly. And I said the data mart can be self-serviced, built by the data analyst, the local data analyst, or IT provided by the corporate IT team of the company. This means that the approach of the data mart can be a top-down approach. It means it's a subset of the data house built from the data house, or can be a bottom-up approach. And this bottom-up approach happens very frequently. This happens a lot of times. What is this bottom-up approach? Many companies have many sets of data spread in different technologies, like many Excel files, Access files, SharePoint files, and this set of files start to grow. They start to grow, to grow, and they become a problem. Is a set of information needed for the operation of that company or for the area of that company. That information is needed. The history of that information is needed as an intelligence information, but is never included in the IT data house, the central data house. So a bottom-up approach is possible. We start building a data mart from this local information. Then this data mart built in a bottom-up approach can evolve into a piece of the data house. So we have the top-down approach when the IT team creates focused data marts to be consumed by specific areas of the company. And we have a bottom-up approach when specific areas of the company have their own data growing out of control, and this data needs to be stored somewhere in a better method of storage. But before talking about Power BI data marts, let's analyze this scenario by another angle, by another point of view. Let's compare what's called exploratory analysis versus explanatory analysis. Many people don't notice that these are two kinds of analysis of the data, and these two kinds of analysis of the data needs to live together. For example, Power BI specialist knows that storytelling techniques are very important to build Power BI reports. Yes, storytelling techniques are very important to build Power BI reports. When these reports are part of an explanatory analysis. When these reports are an exploratory analysis, then the storytelling technique will not help much. So let's compare these two kinds of analysis and what's the purpose of these two kinds of analysis. Explanatory analysis has as target the business users. Who builds the explanatory analysis is targeting to explain something to the business users, while the exploratory analysis is done by data analysts. The data analysts do the exploratory analysis. The explanatory analysis has a conclusion. A conclusion was already discovered in the middle of the data, and the purpose of the explanatory analysis using storytelling techniques is to explain that conclusion and using data as a base for the conclusion, to explain the conclusion. But on the exploratory analysis, there is no conclusion yet. There is a huge amount of data. And the idea of the exploratory analysis is to look for conclusions. A very interesting comparison that I read on a book about storytelling is that exploratory and explanatory analysis. Exploratory analysis is like to open 100 oysters looking for a pearl inside these oysters. While explanatory analysis is about showing this pearl, the conclusion, to the business users, showing the conclusion which was taken from the data to the business users. So the explanatory analysis uses storytelling. The explanatory analysis already has a conclusion to show to the business users, and it shows this conclusion using storytelling. While the exploratory analysis needs research techniques, research tools, needs to find information along the data, find patterns, find combinations along the data, find behaviors along the data, and take a conclusion based on the data which is available for the exploratory analysis. So the exploratory analysis is the analysis to find the conclusion, while the explanatory analysis is the analysis to explain the conclusion to the business users who don't understand about these techniques. And the explanatory analysis finishes with a call to action. Conclusions were taken. The analyst who is building the explanatory analysis has a conclusion and wants to expose this conclusion. And it's important that this conclusion is exposed with a call to action. So we have this data. From this data, we conclude this, and we need to take some action. So it finishes with a call to action, while the exploratory analysis involves discovering what is useful, discovering the conclusion which will be used later to build the explanatory analysis. So one, the exploratory, is intended to find the conclusions to be used by the other, by the explanatory analysis. And why am I highlighting so much this difference? Why am I highlighting so much this difference? It's important for us to think about what Power BI has to offer now, or let's say before the datamart, for each one of these areas. Power BI is great for explanatory analysis. Power BI is absolutely great for explanatory analysis to show a conclusion for the user. And it becomes even greater with another news that came from the build, the integration between Power BI and PowerPoint. The possibility to put a Power BI report inside PowerPoint. Another news which came from build made It's even greater for explanatory analysis. But what do we really have in relation to exploratory analysis? The tools that we have for exploratory analysis, I would say they are a bit complex. We have Power Query, but we can explore the data using Power Query. But Power Query is intended to build the result, to result in a table which we will import into Power BI. So there is an end result intended in Power Query, while the exploratory analysis, the idea is just to move the data around, to make different combinations to find something useful. We can use DEX, we can build reports, we can build dynamic reports, interactive reports, but is this enough to explore the data for exploratory analysis? Is this enough? Many people complain about the consequence of this question. The consequence of this question is the eternal fight between Power BI and Excel. You build that report, the dashboard, which appears to be absolutely great. The user tells you that he loves the report you build. The user absolutely loves the report you built. He loves the report. But then the user comes to you. Couldn't you provide the data of this report in Excel for me, please? Why? What's wrong? If the user loved the report, why is the user asking the report in Excel? Because this user is not a target of an explanatory analysis, and the report you built is not showing a conclusion to the user. The report you built is not showing a conclusion to the user. Just a moment, let me fix one detail here. Otherwise, my laptop will turn off. So now it's better. So as I was explaining, the user, in this case, the user who is asking for the data in Excel format is not receiving an explanatory analysis. He is not receiving a conclusion, and he is not even the target of a conclusion. He wants to explore the data to discover a conclusion, and he is not finding the report, even with being a dynamic report, a flexible report. He is not finding the report as something enough to explore the data. So the user comes back to you and asks, could you provide this data in Excel, please? That's the big difference between explanatory and exploratory analysis, and this huge difference creates conflicts in the market between the Power BI developers and the users of the Power BI developer, because there are different kinds of users. There are the consumers of an explanatory analysis, and there are the consumers of an exploratory analysis. Why I'm talking so much about explanatory and exploratory? This will be clear in a moment. So let's talk about what's Power BI datamart. What is Power BI datamart? Power BI datamart produce an ETL. We can use the datamart to import data, to collect data using Power Query, or we can use data flows as well. We can use Power Query directly in the datamarts, or we can use data flows. Both can be used with our datamart. So the datamart contains an ETL. It stores the data where the data is stored. Behind the scenes, behind Power BI data mart, there is an Azure SQL database. We can work with Power BI data mart without knowing that there is an Azure SQL database underlying this technology. And that's where the data is stored. And Power BI data marts help us to explore the data. We can explore the data visually. We have a visual tool to explore the data and export the data to Excel, or we can explore the data using SQL. We can make a SQL query over the data and export the result of that SQL query to Excel as well. So the Power BI data mart is bringing to us something very powerful. And one of the main focus of the Power BI data mart, not the only one, but one of the main focus of the Power BI data mart is to help the bottom-up process. The bottom-up process, when many data sources, many small data sources start to grow out of control. So the company can import the data from these data sources and build a small database, which is a focused data mart. In the future, that focused data mart built, maybe we could imagine inside a branch of the company, that focused data mart could be used to be part of a data warehouse, could be incorporated in the data warehouse of the company. So it could also be incorporated in the data warehouse of the company. So we have data exploration possibilities inside the Power BI data mart. We have the possibility to solve a huge bottom-up problem in relation to data mart, and we have a way improved set of features to data exploration. Power BI is absolutely great for data explanation, but now it's becoming greater for data exploration as well. So that's why I highlighted so much the difference between data exploration and data explanation. And more about exploration, we have access to the underlying Azure SQL. Yes, we have access to this underlying Azure SQL. Once we build this data mart inside the underlying Azure SQL using Power Query, we can have direct access to this Azure SQL, either to explore the data using queries directly in Azure SQL, or to build data sets and reports, to build new reports and new views of the data directly from this Azure SQL. So the data mart can become a local single source of truth, exactly focusing on a problem that many companies have the bottom-up problem. Many data sources growing out of control, they can be joined together on the data mart scenario. Am I telling that this doesn't work for the top-down approach? No, I'm not telling that. It works great for the top-down approach, but many companies are struggling with the bottom-up approach, and the datamart is appearing as a great solution for the bottom-up approach and provides a centralized model, the dataset. Uh, the datamart will be inside Azure SQL, but the Azure SQL is a relational database. We can build a centralized semantic model using the dataset. There is a dataset together, the datamart, which will contain a centralized semantic model which can be reused by other users of the company. So this is the scenario. We may have many different data sources. Here we can see data sources, many different data sources. So inside the data mart, we can use Power Query to import the data from these data sources. Power Query will import the data and will save the data in an underlying SQL server totally managed by Power BI. SQL Server, more specifically, an Azure SQL database, totally managed by Power BI. Power BI will take care of this Azure SQL database. Then, together the data mart, we have a data set. All the tables inside this data set will be configured with direct query access, direct query storage model pointing to the Azure SQL database. So they will be sending queries directly to the Azure SQL database. And from this point, this can become the single source of truth for one branch of the company. One branch of the company will be joining many data is spread in Excel files, in Access files, in SharePoint lists, and in many other places, and will be joining all this data in a single point, in a single source of truth, which will be the Power BI data mart. Let's see an example about this. Let's see an example about this. So, I will use as an example. You could say that my example will be more of a top-down scenario than a bottom-up approach. Yes, but it's an example of the use of the Power BI data maps. I have here a database, Adventure Works Legal. I have this Adventure Works Legal database. And this database has two special tables called Big Product and Big Transaction History. I shared in GitHub the scripts to build these tables. These tables have a considerable number of rows. So the big product has 14,000 rows, and the big transaction history has more than that, has 8 million rows in the big transaction history. It even takes a while to complete the count in this table. So 8 million of rows in the big transaction history. So let's use these tables to build our data mart. So let's go to Power BI, Power BI portal. The data mart is built inside the Power BI portal, and the data mart is a premium feature, but can be created in a premium per user workspace. So if we have a premium per user workspace, we can create datamart inside this premium per user workspace. No problem. So we can create here a datamart. Okay, so we start with this screen, and the idea is to start importing data. We need to start importing data from our data source. And it already suggests me to import from SQL Server, Excel, and from Dataflow, but I can import from any other data source. The data source is supported by Power BI. So let's start importing from SQL Server. So we see the typical connection environment. So here I can get my server connection, the server address, and use in the Power BI environment. Database, I use ADVWorks Little. ADVWorks Little. Okay, credentials. I put my credentials. What comes next is the typical Power Query experience. The typical Power Query experience inside the browser. So we can use Power Query inside the browser for the Power BI data mart. So I import the big product, the big transaction history. Let's import one more. Product model. Product model. Big product, big transaction history, and product model. And then I'll go to transform this data. So I can improve the name of these tables, the table big product and big transaction history. So let's remove the big from the name of these tables. So product and transaction history. The fields of the table transaction history are quite precise. They are quite precise what we really need. But the fields of the table product are not so precise. We have more fields than we really need, so we can remove some fields from the table product. From, let's say, we can remove size, weight, cell start date, cell end date, and discontinued. And I use remove columns. You may be noticing how it is basically Power Query. And as Power Query always does, it's showing to us how the transformation steps are being executed. Step by step is showing to us the transformation steps. Okay, I brought the table product model, but I don't want to lower the table product model. If I lower the table product model, this model would start to be denormalized. That's not the idea. So I will disable the load on the table product model. I will disable the load on this table. And then on the table product, I will merge queries, merge the table product with the table product model. By which key? I need to select the key, which is the product model ID. So it identified the rows. The rows are correctly identified. Okay, perfect. So now I expand the new table and I'll choose to bring only the name of the product model. The product model ID I already have. The other information I don't need. I'll bring only the name of the product model. And let's rename this column. This column is called name.one. Let's change this name. Let's call this product model name. So I rename it the column. Now, the transaction history table has a transaction date. It's a very good idea in models like this to have a date dimension. This model doesn't have a date dimension. So what I will do, I will use an example from the web. This example was published by Chris Webb. I use a code to create a date dimension dynamically. Dynamically create a date dimension. In a typical Power BI model, I would not like too much about this idea. I will not consider this idea of dynamically creating a date dimension as a really good idea because the date dimension would be dynamic. But in this environment, in the datamarts, once we create the data dimension using Power Query in the datamart, the data dimension will be stored inside Azure SQL. And in fact, what we have is a physical table containing the data dimension. So this is a good idea for the Power BI datamart. So we can create here a blank query and here I'll paste the M code use it to build a data dimension from quiz web. Next, this code is in fact a function, and I need to pass two arguments and invoke the function to generate the data dimension in this example. Let's give a name for this function. Let's call this function as build date dimension. Build date dimension. This function will build the date dimension for us. The date dimension needs to contain all the dates on the transaction history. And this function requires a start date and an end date. It's a very good idea if I can get the dates from the transaction history dynamically. If I can get the minimum date and the maximum date from the transaction history dynamically to build the date dimension. I can do that. So I will generate two other informations. I will generate the starting date and the end date, and I use this information for the uh, the build date dimension. So let's duplicate the transaction history query. Why duplicate? Why I'm duplicating the transaction history query? Well, there are two options in relation to this. I can duplicate or I can reference. If I duplicate, I'm creating two queries. Yeah, true, I'm creating two queries. But this is a very sensitive decision which has many factors to make us decide if we should duplicate or if we should reference the query. In our example, each one of these queries will result in a SQL query. The end result of all these queries will be a SQL query. So the duplicate ends up being the best result. In fact, I published a blog post in Simple Talk explaining exactly this scenario. Why the duplicate is better in this scenario than the reference. It's not something easy to identify. You can take a look on that blog post in Simple Talk later to discover why the duplicate is better than the reference. So let's go to the first one. I will select the transaction date column and I will choose to remove all other columns. I'll keep only the transaction date. Remove all the other columns. Then I will sort this content ascending. Sort the transaction date ascending. That is it. So since I sorted ascending, so the first date that I have is the minimum date in this table. So I can use reduce rows and keep rows, keep top rows, and I'll choose to keep only one row. One detail when we are working with Power Query, one detail which makes a huge difference in relation to performance when we are working with Power Query is if this query this transformation is generating a native query to the data source, or if this transformation is being executed by Power BI. This web interface for Power Query shows to us the answer. We just need to pass the mouse over the transformation and it tells us this step will be evaluated by the data source. So it will generate a native query. This by itself doesn't mean that the performance is perfect, but we are in a good direction. Then we can check view the data source query, and we can see the query which will be generated to the SQL Server, the source of my data, the SQL Server. So here we can see the query generated to SQL Server. And it's quite a simple query. Quite a simple query. Bringing one column with a top one and an order by. Okay. Now that I did this, I need to remove the time. When we are building a model, we never mix the time with the date in the same dimension. Time and date should be two different dimensions, never the same dimension. If I really had meaningful time on these fields, I would need to create a different dimension. But since I don't have meaningful time here, these times are all 12 a.m., all midnight. So I can just change the data type here, transform, change the data type to be only date. So I change the data type to be only a date type. Mind what happened with this last transformation. This last transformation, Power BI is executing outside the database. Power BI decided that this last transformation would be better executed outside the database than inside the database. And it's interesting, the sequence that I used, I made all the records transformation to find the information that I would like. And the last step was to transform that information to the format that I was willing to get. If I had done this in a different sequence, the resulting query to the source database would be terrible in relation to performance. That same blog post where I explained the difference between duplicate and reference, I also explained this difference of this sequence and why we should leave data transformations as the last steps of the transformations in Power BI, in the Power Query. This is the minimum date in the transaction history table. Min date will be the name of this table. Okay. And in fact, I doesn't need this query to be loaded to the model. I don't need min date in the model. I will use min date as a parameter to my function to build the date dimension. I don't need the min date in the model. That's another interesting detail. Then we have here the second copy of the transaction history, the second duplication we did of the transaction history. I will give a name of max date for the second duplication of the transaction history. And I'll do the same steps, but I order in the reverse order. So I will select the transaction date, remove other columns, then I will make the sort descending. This will bring to me the biggest date on the top. Okay. Then I will use the keep rows, keep top rows, and keep only one single row. And finally, as the last step, I make a transformation to change the data type, data type to be only date. I will not load this query as well. I will disable the load of this query. Okay, disable load. Then on the build date dimension, on the function that I copied here, the build date dimension function, I will define that the start date will be a query, and I will select the query. Which query? The query mean date. Sorry, before selecting the query, there is one more step that I need to do here on these tables, because this is still let's say a set of data table. I can right click and use the drill down to get only the date as a result, only a single value as a result. That's it. And I need to do the same for the max date. I drill down to get only a single value as a result. That's great. So here in the build date dimension, I will select the query for the minimum date, min date. I will select another query for the maximum date, max date. I'll click invoke. This will create a new query executing this function. And this new query executing this function will bring as the result my date dimension, the date dimension for our model. That's it. I have the date itself, and I have all the pieces of the date isolated in different fields. This date dimension totally replaces those dynamic data information generated by Power BI automatically unless you disable that property. That property is terrible for performance. And here I will call the result of this function as date dim, date dimension, and save. On this moment, the data mart will load the data from my data source. Now the data mart will be loading the data from my data source. We'll need to wait some moments. The example with the data dimension is a very interesting example. What makes this example especially interesting is the fact that we can uh, turn into something physical a dimension which otherwise would be dynamically. We can turn it into a physical dimension inside the underlying SQL, and this will make the performance better for the environment, creating a real data dimension. It's almost finishing. And finally, it's done. Wrapping things up, and it's about to finish the load of the data. This data is being loaded in an underlying Azure SQL that we are not seeing immediately now. We are not immediately seeing this underlying Azure SQL. So this is the appearance of the datamart environment after we executed our Power Query ETL. After executing our Power Query ETL, this is how the datamart environment is. So what options do we have here? We have some very interesting options, like for example, manage roles. We can manage roles and create role-based security for these tables. That's possible. Once I select one table, I can use incremental refresh. I can make configuration of incremental refresh for this table. When the ETL is executed again, refreshing the table, it can implement incremental refresh policies. I can create meshes here, and we can build our model. After the ETL, we build the model. So let me increase this a bit. So let's create the relationship between these tables. So the transaction history is the fact table. Let's put the transaction history in the middle. It is the fact table. And then put the product in one side and the date dimension in the other side. Let me link the product ID with product ID in the transaction history. And we can create a relationship in our model from product to transaction history. Manage one? No. From product to transaction history is one to many. one-to-many relationship. And then dating, I can create a relationship between dating and transaction history using the date field and the transaction date field. From dating to transaction history is one-to-many as well. So I built the model inside the datamart. So we started with DTL, we built the model. But I also highlighted how the datamart has exploratory features. Yes, the datamart has exploratory features. For example, I can run a SQL query over my model. I can run a SQL query over my model. For example, select from a transaction history in a join in transaction history transaction date equal the date group by, let's group our information, group by, let's take a look on the information that we have in the date dimension. I have the year, let's group by year, month, number of year, month name, so I can retrieve the field. Okay, so let's include here year as a result, month name, and let's make a sum of the information from transaction history. Let's get the actual cost. Let's make a sum of the actual cost. So inside Power BI, I'm executing a SQL query over the model that we just built. And it's bringing the result for us. I didn't give a name for the last column. There is a trick here because the query becomes hidden. I need to change the size of the window so I can see the query again, and I can give a name for this last value as total sales. So I have the total sales by month and year. And this total sales by month and year is an example of exploratory analysis. I'm exploring the data to discover something from the data and get a conclusion, reach a conclusion from this information. And here we are also solving the problem of the users. Those users who always ask, could I have this data in Excel? Yes, you can. Go to the datamart, execute the query, and clicking open in Excel. So the user get an Excel spreadsheet. The user get an Excel spreadsheet. I can open it. This is how the spreadsheet appears immediately after it's open. I need to enable editing. And then enable content. Let's wait some moments. It's loading the data, it's still loading the data. It confirms the execution of the query, and it's going to execute this query that I created in the Power BI datamart directly over the underlying Azure SQL. My current credentials, no, I need to sign in with a Microsoft account. I need to sign in with my Power BI account to authenticate to this underlying SQL. Sure, I'll be publishing the recording on YouTube. You can get the recording for your reference. Uh, Give me some, I will need some days to get the recording and edit some time, miss a time, and so on. But then I'll publish on YouTube and you have the recording for your reference. What do you think? Will it be useful for your scenarios in the company you work for? Let's wait a bit. For some reason, it's taking a while to show me the authentication page. Let me close it and try again. Signing, I need to put my Power BI authentication. Now, yes. Okay. So I need to use my Power BI authentication to execute any query over the underlying SQL Server created by Power BI. Underlying Azure SQL database created by Power BI. Then I connect. And there it is. I have the data resulting from my query, the query that I built in the datamart environment, and I got the data as a Power BI spreadsheet. This is the possibility to directly execute a SQL query on the model and get the result as a spreadsheet, improving the capabilities to explore the data and solving that eternal problem, solving that eternal dilemma of the user always requesting So it appears my camera failed for some moments. So it's back. My camera failed for some moments. So I was explaining that this capability can help solve that eternal dilemma of the users always asking to see the data in Excel. So we are providing this. We are providing then an exploratory analysis capability. And besides the query, we can also use this other view to explore our data. Let's see an example. Let me get transaction history. I drag a transaction history to the middle of the screen. It takes a moment to load. So it loaded transaction history. And what we have here is a visual approach to build a query over our data. So I brought transaction history. I can create a merge between the transaction history and the date dimension. Merge queries. So I merge the transaction history is the first one. Oh, sorry. I need to bring the date dimension as well to the transformation, then I can merge the queries. So the point is I can make Power Query operations inside this environment, like put multiple tables here. I'm not sure if the environment is low in this example, but it's a preview feature. Let me try again. The idea of this tab called design is only to explore the data. So once I leave the tab and get back, so I can start again exploring the data. This time I started from the date dimension. I dragged the date dimension to the middle of the screen. There it is, the date dimension in the middle of the screen. Now I drag the transaction history in the middle of the screen as well. So I'm including two tables to explore. I can merge queries. The date dimension with the transaction history. I merge based on the transaction date. I'm sorry, this example will not work so perfectly because the columns are not of the same type. The columns don't have the same type. Let me get the transaction history here. I can here during the exploring of the data to include a data type change, but the perfect solution would have been to include this data type change during the Power Query, during the ETL. But since I really forgot that step, so I'm including here while exploring the data. I included the data type change, then I can merge the queries. Now that I changed the data type, I can merge the queries and they will have the same data type. The transaction date and the date on the other table will have the same data type. So the tables are now meshed. This is the result of a meshed query. Let's choose what fields I would like to bring from the date dimension. From the date dimension, I would like to bring the year and the month name. Okay. So I brought the year and the month name. And now I can make a group by. I can group by this result by year, month name, and I can add the result. I can add the count of rows, quantity of sales is the count of rows, and I will add a new aggregation. Total sales will be the sum of the actual cost. Okay, and it will do this aggregation for me. What's the idea of this task? The idea is that I'm exploring the data. First, I illustrated an exploration where I had to use SQL. I used the SQL query to explore the data. Okay, anyone who knows SQL can do that. But what if the user doesn't know SQL? The user knows nothing about SQL. In this case, the user can visually explore the data using Power Query over the model. Using Power Query over the model which is already built. Okay, we saw the example. We are noticing a small bug here. We are noticing a small bug here on this point. But we saw the example working. That's the idea. Okay, let's get back to the workspace, datamarts party. And a data mart was created for us, and then a data set is created for us. This data set contains the model, while the data mart is the responsible for the ETL and for maintaining the underlying Azure SQL. So I can rename the data mart. The initial name is not very interesting. I can rename it, of course. Sorry that my machine appears a bit slow. I hope it's only my machine, not the portal. Uh, it's because my original laptop decided to die this week. It died. It completely died. And I stole the laptop from my wife. I'm using my wife's laptop for this presentation. So I'm renaming the data mart. So I can here rename the data mart. Let's call inventory sales. I rename the datamart, and once I rename the datamart, the dataset is renamed as well. So the name of the datamart and the dataset, they follow each other. They are linked one to the other. And let's take a look on the datamart settings. Inside the datamart settings, we can find the server settings and the connection string. This connection string can be used to get direct access to the underlying Azure SQL. So I can use this in an SSMS environment, for example, database. I use the connection string to get direct access to my underlying SQL. The authentication will be an Azure authentication using MFA, and I'll use my Power BI account. That's it. It's requesting my authentication. Meanwhile, it's opening, but meanwhile, let me open Power BI desktop, and Power BI is opening, but now we can see here a connection to the underlying database behind the datamart. We have an Azure SQL database behind the datamart. Here is the Azure SQL database. But if we check tables, there are no tables in this Azure SQL database. No tables here. Why there are no tables here? Because all the tables that we built using the datamart, they are exposed, in fact, as views. The datamart controls in deep details the physical structure of the tables in the database. So what we see are in fact views. Transaction history, product, date dimension, and we can query these views directly if we would like so. I could build a query over these views directly. But now I have Power BI opening. Let's wait it to open. Then we'll be able to see an example using Power BI. Meanwhile, since Power BI is still opening, I can execute a query over these views. I can build that same query. Select from transaction history inner join dating on transaction history. Transaction date equal dating date group by dating year month number of year and month name. That's it. Then I can select these same fields. Select these same fields that descend of the actual cost as total sales and execute this query. So I'm executing a query directly over the underlying Azure SQL generated by Power BI, by the Power BI datamart. And here I already have Power BI open. It seems a bit blocked. Just a pop-up. Okay, but I don't want to see the pop-up now. Okay. So I have Power BI here, open. I can use get data. Sorry, my machine is in Portuguese, so it will be a bit more difficult to understand. But I'm using get data from SQL Server. And then I go to Power BI portal to copy the string again. Let's wait to get data open. So I put here the server. Okay. I need to provide credentials, so I need to authenticate using my Microsoft account, my Power BI account. Okay. And connect. Let's wait some moments and the new window comes, bringing the database for us and showing the views that we built inside the datamart. So in this case, I use the underlying SQL as a direct source for my new report. I'm using the underlying SQL as direct source for the report. This is good. This is interesting. But there is another method as well. Instead of using is complaining about old files. Instead of using the underlying SQL, I can use a data set as a source. So I'm defining a data set as a source. I need to connect using my Power BI account again. Then the point here is that we have two possibilities to build reports from the datamart. One of the possibilities to build the report is to build the report based on the underlying Azure SQL. The second possibility is to build the report. Let me locate here the workspace. Datamarts Party Adventure Sales, based on the data set which follows the datamart. So I build a report over this data set, create the report, and then I'm getting the model from that data set. The difference is that if I go to the underlying SQL, I need to import the tables and build the model. But if I get from the data set, I have the model already built for me. So the model which is built inside the data set of the data mart, can be a single source of truth for how a company branch or a company region, that model will be the base for all the reports built for an area of the company. So it brought to me the model. I can take a look on the structure and I will see the model built on that data set. The relationships that I built, every detail on the model that I built on that data mart is brought to here. That's the idea. So we have these two methods to build reports over the content of the data mart. So the data mart can easily become a local single source of truth for an area of the company. And it can be a top-down process where the data mart becomes a subset of an existing data warehouse, or can be a bottom-up process where an area of the company organizes a lot of information out of control into the data mart, and this data mart will later evolve to become part of a data warehouse. That's the idea of the Power BI data mart, and that's how it fits with the architecture that we already use so much of Power BI. Any questions, any additional questions, any additional detail you would like to know about the Power BI data mart?